Hey, Algebra 2 students, in this video we're going to be factoring quadratic equations using the column method. Here's our objective: students be able to factor polynomials of this form using the column method. In the last video we used our diamond box method. This is a slightly different approach, so our goal here is for you to try this one out, see if you like it. If it works for you, you can use it every time you factor. If you like the diamond box method better, that's fine too. Feel free to use whichever works best for you. So in this method, similar to the diamond box method, we're trying to figure out how to break up this quadratic into two factors that are linear. So they have some kind of x term and some constant term. The way we're going to do that is to first figure out our factors of our first term and our last term, and then they need to multiply and add up to our middle term. So that's our goal. But here's how we're going to organize our work. So we're just going to make a column here below the first one, the first term, the ax squared term, and a column below our last term, the c term. Now in these columns, we just need to list factors of the numbers we see. So for the first one, x squared, I think two things that multiply to make x squared, well, definitely just x and x. X times x would give us x squared. So those are two valid factors of that x squared, the first term. For the last term, we need two factors that multiply to make 63. So off the top of my head, I think there's only a couple of these. I think 7 and 9 multiply to make 63. Yep. So I'm just going to put 7 and 9 in here. Then cool. So at that point, we've gotten factors of each of these. Now what we're going to do is we're going to multiply across like this, x with 7 and x with 9, and then add them up to see if we get our middle term, negative 16. So let's try that. 7 times x is 7x. 9 times x is 9x. And if we add those up, 9 plus 7, we get 16x. So it looks like we were pretty close here, except our sign is wrong, right? We got a positive 16. We needed to get a negative 16. So if I did this the other way, I need two factors now, a different two factors that multiply to make positive 63 and would add to make negative 16x. So I need some negatives in here, so I need to use my negative factor. So I'm going to cross out that option and make a new column where we're going to guess our factors. Instead, I'm just going to guess negative 7 and negative 9. Because I know negative and negative will still multiply, make it a positive 63, but they might help us get to a negative 16x when we add them. So now if we do this again, we're going to multiply using our new factors. So negative 7 times x, negative 7x, negative 9 times x, negative 9x, and then negative 7 minus 9 gives us the negative 16. Right. So now we've picked a different set of factors that does indeed add up to negative 16. And then the way we get our factors for this is just by reading the terms like this. So x and negative 9, that's a factor, x minus 9. And the first factor is x minus 7. This is where we get them. So overall, we took our first and last term, we put their factors in columns. We multiplied across like that and added up to see if we got the middle term. And then if it didn't work, we crossed out, made a new column with different factors that might work, and then tried it again. So let's try again on this next one. Factor the expression below. Here we have a leading coefficient on our x squared term, which will kind of be a little challenging. And then over here we have negative numbers. So this is a good kind of extension one. Again, I'm going to make my columns. Things that multiply to make 7x squared. Well, here there's actually only two things that would, 7x and x, because 7's a prime number. It doesn't have any other factors other than 7 and 1. So I'm going to put 7x and x here. And then for factors of 20, I'm going to list some options over here. There's always 1 and 20. There's 2 and 10. And 4 and 5. That's all I can think of right now. So those are probably the ones we're going to guess on. Why don't I just go down the list? I'll start with the first one, 1 and 20. Here we're trying to make a negative, so I'm going to make one of them negative. I'm going to go let's say -1 and positive 20. Right, so I just took a factor of -20, put it in a box. Now we're going to cross and add up. So -1 times x is -x. 7 times 20x, or 7x times 20 is 7 times 2 is 14. So 140x equals 139. Not even close, right? We needed to get to -31. So I don't like this factor pair. I think it's giving us two numbers. So I'm going to cross it out, and we're going to pick a new one. How about the 2 and 10? Let's do, again, we'll just do a -2 up here and a 10 down here. If I multiply, you get -2x, and then 7 times 10 is 70x. 70x. So that would take us to 70 minus 2 or 68x. Again, it's not really what we needed. Too high. So let's try the next one. So these factor pairs haven't worked so far. Gone. Next we have 4 and 5. Again, I'm just going to do -4 and positive 5. Multiplying -4 and x, that gives us -4x. And then multiplying 7 and 5, that gives us positive 35x. And then that gives us a total of positive 31x. Okay, so this time we're actually pretty close. It's the right number, just the wrong sign. So if I'm going to have to make one more guess, I need to change the signs of these. So I'm just going to make it instead a positive 4 and a -5. And then our last multiplication is going to give us 4 times this. So positive 4x. And then -5 times 7, -35x. And then gives us a -31x. Great. So again, to get our factors, we just pick them straight across like this. So this altogether factors into 7x plus 4 from the top pair, and then x minus 5 from the bottom pair. I'll highlight these so we can see where we got them. So in this one, to summarize, we really had a few steps here. First, we just made columns. Under the ax squared and the c term. Remember, our polynomials, our quadratics are in the form ax squared plus bx plus c. So we made columns under ax squared and c. And then we guessed, we just really just put down factors of ax squared and c in the columns. And then we multiplied and added diagonally. To try to get bx, right? If we multiply and add, that's when we did our cross. Like up here in this example, it was -1 times 7. For the first try, it was -1 times x, and then 7x times 20, and then we added them up to get this 139x. And we saw that guess was wrong, but then we were just able to fix it. So multiply and add to try to get bx. And then we really just repeated 2 through 2 and 3 until we got bx. Right? We tried different columns, different factors until it worked out. So again, this is just one other way to factor. If this works for you, that's great. If you like the diamond box method better, that's fine too. On the back of this, there are 1, 2, 3, 4 questions to try this out on. Some of them have no leading coefficient, they just have 1x. Some have leading coefficients. Down here, we can do the same thing whether we have an x or not. For example, factors of p would just be p and p. P times p would give us p squared. So it doesn't always have to be x's, it could be other variable names too. All right, try these out, check your answers with your intervention teacher, and I will see you next time.